Okay, class, this is Mr. Munguia speaking to you. I trust that the substitute teacher has just pressed play. I just wanted to cover just a few refresher examples of what you'll be doing today in class in your assignment, which is assignment 11. Actually, strike that. Assignment 9. Assignment 9 you guys will be working on. Recall that last week we talked about a roots of a function. It's the point where the function crosses the x-axis. So if I were to graph this function, which is actually quadratic, notice, we know it's quadratic because the highest exponent is a 2. Wherever it crosses the x-axis, so to make a quick graph here, wherever it crosses the x-axis, let's say it's a parabola that opens down or something. Let's say that was a graph. These points where it crosses the x-axis are the roots. So that's what we're referring to. The roots are the points where a graph crosses the x-axis. And we already know, and we spoke about how anytime you have a root of any type of polynomial, no matter what the graph looks like, we know that we have x is your first coordinate and f of x is your second coordinate. We know that f of x will always be 0, right? No matter what x is, f of x will always be 0 at the roots. So that always involves us making f of x equal to 0. In other words, rewriting the function, making f of x, setting it equal to 0, and solving the equation for x. Now, we talked about last week and yesterday how if we're going to solve for x in a polynomial-like equation, then we actually have to factor it and set each factor to 0. And that'll result in all the solutions to the equation. So let me get into the first example. Notice we have a cubic function, and notice how the equations I'm going to throw at you on assignment 9, the equations are already set to 0. In other words, you don't have f of x here to start off with. They've already replaced it with 0 here. Notice, okay? So all the equations for assignment 9 will have 0 to start off with, and you'll notice that. So the way to solve this equation is we're going to factor. All the factoring techniques I've taught you for the first 3 weeks of this quarter are going to be involved in solving for these polynomial equations. Now, noticing, remember the well-known factoring patterns handout I gave you last Friday and yesterday. You're going to be using that handout because that's a good summary of all the techniques we went over, except the greatest common factor technique. A lot of you already still have the tree map, the 6 ways tree map of factoring. You guys can use that as a tool to bring to memory all the techniques that I've taught you. But here, I'm looking at this. We have a binomial. It's not a difference of 2 squares. Notice that, so I'm not going to use that technique. But I do see a common factor of 2x squared. They both have at least a 2x squared, so I'm going to take out a GCF of 2x squared. And what does that leave us with? Well, 2x times x will give us the 2x to the third minus a 3, notice. So I used a GCF method here because I was able to. Now, at this point, I have a monomial, and here I have a binomial. Notice that. I'm done factoring. I can't factor any further. This binomial here, x minus 3, is done. I can't go any further, and this monomial is done. So what I'm going to do now, since both of these factors, both the monomial and the binomial, have the variable x in it, we're trying to solve for x, I'm going to set each factor equal to 0. So watch this. I'm going to go ahead and set 2x squared equal to 0. Notice. I'm setting it equal to 0. And then I'm going to set this binomial x minus 3 equal to 0. Watch. And it just so happens that both of these equations are going to result in the solutions to this cubic equation. Remember, I say cubic because the highest degree, the degree is 3. So the type of equation we're dealing with is a cubic equation. So now notice, we have this, let's start right over here, this solve for x. Here, I have a quadratic equation. Here, I just want to get x by itself. So what I'm going to do is first divide by 2 to get x alone. I end up having x equals 0 divided by 8 is 0. So x to the second power equals 0. What does x have to be? Well, let's take the square root. Recall from math 2 that square rooting gets rid of the second power. So I'm done here. X is equal to the square root of 0. What number times itself becomes 0? Well, it's 0. So there's one solution, right? X equals 0. And over here, the second solution is going to be x plus 3 equals 0. So I'm going to add a 3 to both sides. Notice. So I have x equals 3. So this cubic equation, this cubic function has two solutions, x equals 0 and x equals 3. And notice that we're able to obtain these solutions by factoring. We use the GCF method that we worked on. We took the greatest common factor, then took each factor and set it equal to 0, and it resulted in our solutions. Here's our next example. Here we have a 4-term polynomial. So here what we're going to do is we're going to, I'm thinking of the technique I taught you that involves 4 terms. And I'm right away thinking of factoring by grouping. So recall, we're going to group these 2 terms together and group these 2 terms together. And let's see what we get. Here, the greatest common factor is going to be an x to the 3rd power, notice. I'll take out an x to the 3rd power. That's going to leave us with an x plus 7, notice. And over here, I'm going to take out a negative 8. I'll take out a negative 8, notice. I'll factor out a negative 8 from here and here, okay? And that'll result in x plus 7 also, notice. So factoring by grouping, I now have x plus 7, right? In other words, the binomials are in common. So by factoring by grouping, I'm going to extract the x plus 7. So I'll have x plus 7 finally times x cubed minus 8 equals 0. Notice that. So at this point, I have a difference of 2 cubes right here. So what I'm going to do is factor that out using the difference of 2 cubes pattern. The x plus 7, this binomial is done right here, but here I see a difference of 2 cubes. In other words, I have x to the 3rd minus 2 to the 3rd. Notice how I'm writing it in the difference of 2 cubes structure. Let me bring this one down here. Okay. So let me follow the pattern. Recall, a difference of 2 cubes ends up being a trinomial and then a binomial. Okay, so in this case, it's going to be x minus 2, because your x is your a and your b is 2. So x minus 2 times x squared plus 2x, that's ab, plus b squared. In this case, 4. Okay? And now I have the x plus 7 over here. Notice that. So, at this point, I have a binomial factor, another binomial factor, and then a trinomial here. So at this point, I'm going to go ahead and set these equal, the first 2 binomials equal to 0. This trinomial here cannot be factored. So as I taught you yesterday, this is a quadratic trinomial. And I taught you the quadratic formula yesterday, which is, so what we're going to do here is we're going to set this trinomial equal to 0. X squared plus 2x plus 4 equals 0. And we're going to use a quadratic formula because it just so happens that I cannot factor this trinomial. So we'll have to use a quadratic formula. So x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So that's going to become negative b, in this case, is going to be negative 2 plus and minus. We have b squared minus 4 times a is 1, and then c in this case is 4. Notice. All over, so I got negative b plus and minus all over 2a, in this case 2a, 2 times 1 in this case. Okay? So right now, I'm just focusing on this trinomial. I'm setting this one equal to 0. I'm going to solve for x. So we have x equaling negative 2 plus and minus. We have 4 minus a 16, which becomes negative 12. Let's see, 12, yeah, so it'd be a negative 12. The square root of negative 12 all over 2. Now, for now, the square root of a negative number, I'm going to talk about when I get back on Thursday what to do with that kind of situation. But for now, our two solutions would be, as far as this trinomial goes, our two solutions for this trinomial, again, I'm right here. For this trinomial, the two solutions that result from that are x equals, let me get this going here. X equals negative 2 plus and minus negative rad 12 over 2. These are your two solutions. Negative 2 plus square root of negative 12 divided by 2 would be one solution. Negative 2 minus square root of negative 12 divided by 2 would be your second solution, but that's not it. So you have two solutions here for x, but we still have other factors that we have to set equal to 0. We still have this x minus 2. Let's set this equal to 0. And x plus 7, let's set this equal to 0. So let me bring that over here. So I'll just bring down here x minus 2 and x plus 7. So x plus 7 equals 0, and x minus 2 equals 0. So let's subtract, let's start with this simple equation first. Let's subtract 7 from both sides here. So x equals negative 7. Over here, we'll add 2 to both sides. X is equal to 2. So we end up having 4 solutions. X equals negative 7 is the first one. X equals 2 is your second solution. And then you have 2 complex solutions. Again, I'm going to talk about this situation with a negative square root when I get back from Phoenix, just so you know. So we end up having 4 solutions here. So what's the moral of the story? The moral of the story is when you have a polynomial equation, this is what we started off with. Here's your polynomial equation. You use all the factoring techniques I taught you, and once you've factored it completely, you set each factor equal to 0. Okay? Let's go on to another example. Hopefully this one will be a little easier. So here I have a binomial. I believe this follows a difference of 2 squares pattern. So remember, you have the handout I gave you yesterday and on Friday on well-known factoring patterns that I summarized all the factoring techniques. So this is a difference of 2 squares. Let me rewrite as a structure a squared minus b squared. Let me see if I can rewrite it this way. So let's see, that'll be x squared squared minus 4 squared. So now I know what my a and b is. My a is x squared and my b is 4. Let me follow the pattern then. So the difference of 2 squares pattern says a plus b times a minus b. Right? So I have a binomial and a binomial. But now this binomial here also follows the difference of 2 squares, so I can factor out completely more. I can't stop here. I got to keep going until I've factored it completely. This one is done right here, x squared plus 4, because that doesn't follow any factoring pattern, so that's factored completely. But over here, let's factor this one. This will be x plus 2 a plus b times a minus b, in this case ax minus 2. And over here, I have x squared plus 4. Now let's set, so I have 3 binomials in the end. I can't factor any further. I have x squared plus 4 is a binomial, x plus 2 is a binomial, x minus 2 is a binomial. 3 binomials, I'll set them all equal to 0 now. So up till now, it's just factoring techniques that you've learned. Now let's set each binomial equal to 0. X squared plus 4 is equal to 0. X plus 2 is equal to 0. And x minus 2 is equal to 0. So let's subtract 4 from both sides. So I have x squared equaling negative 4. I'll take the square root. And so I have x is equal to a positive and negative, the square root of negative 4. Again, when I get back from my vacation, how do we handle negative square roots? But for now, we have 2 solutions. Positive square root of negative 4 and negative square root of negative 4 for now. Over here, I'm subtracting 2. X is equal to negative 2. And over here, I'm adding 2. X is equal to positive 2. So we end up having 4 solutions. Positive and negative square root of negative 4. Negative 2, positive 2. Here's all of our solutions right here. Okay. And the last example. The last example is a trinomial. Here, I'm going to go ahead and factor this trinomial into 2 binomials. That is the factoring trinomials technique. So I need x and x here. I need 2 numbers here that multiply to become positive 4, but add up to be 5, and that's going to be positive 4 and a positive 1. Positive 4 times positive 1 becomes 4, and then 1x, the outsides, and the inside's 4x. If you add those up, they become 5x. In other words, the middle term. So we're good to go. We have our factors. Now let's set them both equal to 0. So we have x plus 4 equal to 0. That's the first binomial. And I'll set the other binomial equal to 0. We'll subtract 4 from both sides. X is equal to negative 4. We'll subtract 1 from both sides over here. X is equal to negative 1. Here's both of my solutions. These are the numbers that satisfy this quadratic equation in this case. So we've covered a quadratic. We've covered a quartic that involved difference of 2 squares. We covered a quartic that involved factoring by grouping. And we covered a cubic that involved greatest common factor. So we've done 4 examples. I trust that's going to be sufficient for now. I'll see you guys Thursday. Again, just get to work now. We'll have assignment 9. Be productive. And see you guys Thursday. And you'll see one more video tomorrow that the substitute will play. Okay? Talk to you guys. Love you guys. Bye-bye.